in a little bit.
I love that.
So welcome back to Mr. Strauss's Chemistry Corner. I know it's been a while. To my friends in Poland, Przepraszam, and my friends in Germany, Guten Tag. We're going to go through the test. No animals were hurt during the filming, and this is recorded before a live studio audience. All right. So let's go through the answers to the test. Number one is A, pressure is force divided by area. Number two, the energy required to change 1 gram of a solid to a liquid is C, enthalpy of fusion. Number three, a volatile substance will evaporate quickly. So A, if it has a high surface tension, it would mean it would have strong intermolecular forces. But if it's evaporating quickly, it can't have high, if it's evaporating quickly, it would mean that the bonds are very strong and therefore would have high surface tension. So it can't be B because a volatile substance evaporates quickly. And it can't be C because if you had strong intermolecular bonds, then you wouldn't evaporate quickly and therefore you wouldn't be a volatile substance. All right, figure 1. What's the triple point? In figure 1, the triple point is letter H, right in the middle. There's your triple point. What is the phase at point B? Well, this is solid. This is liquid. This is gas. So even though point B is way down here, you are still a gas at that phase. So B is gas. What happens when you go beyond the critical point? Letter I is the critical point. If you go beyond that, you're not a liquid, you're not a gas, you are a superfluid. So when you go beyond that point, the density of the liquid and the gas are equal. Letter D. At 250 ATM, what's the boiling point? This is the freezing line. This is the boiling line. So when you're on that line, you are boiling. At 250 ATM, you would boil at about 125 Kelvin. So the answer is 125. Where are you sublimating? This line is the sublimation curve. So on letter G, you are going to be sublimating. Where is the critical temperature? This is the critical point. The critical temperature will be somewhere again around 130 Kelvin. Or you might have put point I. So either one, point I or 130 Kelvin. So on the retake, you'll have a graph like this again. Obviously, it's not going to be the same identical graph. The idea is that I'm testing your skills, not your memorization ability. So you'd have a different graph, different points. Questions? You want to make sure you understand this so that if you're going to retake it, figure 2. Where does melting begin? So in this section, you're heating your solid, and your solid is getting warmer and warmer and warmer and warmer and warmer. When you hit point A, that's when the melting begins. You start to melt at point A. So that's 5A. what is the numerical freezing point? Well, the freezing point and the melting point are the same, right? When does water freeze? At 0 degrees Celsius. When does ice melt? At 0 degrees Celsius. If you're doing Fahrenheit, when does water freeze? 32 Fahrenheit. When does ice melt? When the temperature reaches 32 Fahrenheit. So this plateau is the melting point and the freezing point, and so that's about 125 Celsius. So where is their liquid going to be present? And this one was worth 3 points. If you're beginning to melt here, there must be liquid in section 2 because you're melting. In section 3, you've got liquid. And in section 4, that's when you begin to boil. Well, if you're starting to boil, you must have some liquid. So in these 3 sections, you have liquid. Okay? Here you're a solid. Here there's some solid. It's melting. By the time you get to point B, all the solid is gone. Here's where you begin to boil. By the time you get to point D, all of your liquid is gone. And in section 5, all you have left is gas. Now for the fun stuff. Manometer problems. Ooh, let's see. Christoph, could you read number 6?
Christoph?
You are now.
Okay. A closed manometer is connected to a container of neon gas. The difference in the height of the mercury in the 2 arms is 517.5 millimeters. What is the pressure in kPa?
Okay, closed manometer. It's, with a closed manometer, the height difference is always higher in the closed end arm. The height difference is 517.5. The pressure is just the height difference. That's the pressure. So all you have to do is convert to kPa. That divided by that. We've got 3 sig figs, 6 sig figs, 4 sig figs, so our answer will have 3 sig figs. It'd be 69.0 kPa. And if I made a mistake on your test, just let me know. I can give you the points at the end. Number 7, we've got an open manometer. With the open manometer, we have to do a little bit of thinking. You've got the air pushing down, and the pressure of the atmosphere is 97.2 kPa. Then you've got the gas pushing, and you have to figure out which one's stronger. Well, what are the heights of the liquid? It says that it is 180 millimeters higher in this side. So if it's 180 millimeters higher on this side, then who's stronger, Ian, the gas or the atmosphere? The gas, because it's pushing the mercury up into that side. So if the gas is stronger, you're going to add the height difference. So we would do 97.2 plus the height difference, But of course, Pashemik, the units have to be the same. So that means I have to convert. All these conversions are on your appendices. Three sig figs, 5 sig figs, well, that's 6. 3, 6, 3, and 3, so we round our answer to 3. So the pressure of the gas is 121 kPa. The conversions, you guys, I think everybody got these right. All you got to add is, for letter A, negative 20 plus 273 gives me 253 Kelvin. For letter B, we got 450 Kelvin, so I'm going to subtract 273 to get to Celsius. And we've got 0 Kelvin, so minus 273 to get the Celsius. So any questions on that page before I go to the next one? Oh, we still have to do number 8. So number 8 was worth 11 points. When you see a problem that's worth a lot of points, you should think there's a lot involved. And so, how much energy does it take to turn 10 grams of water into 35 grams of steam? So, here's our starting point. It's at 35 degrees Celsius. How hot can you get water? Can you have a glass of 60-degree water? 70? 80? What happens when you hit 100?
Starts to evaporate.
Starts to boil.
Oh, yeah.
So you can't get higher than 100. And that's your final, that's your initial when it comes to section number 1. So in section number 1, you have M delta T Cp of water. The mass is 10 grams. Specific heat of water is 4.184. But this is where most people made the mistake. The final temperature is 100. The initial temperature is 35. So when I plug it in, final minus initial, when I do this subtraction, I end up with 65. 65 is 2 sig figs. That is 3 sig figs. That is 4. So I'll round my answer to 2 sig figs. Yeah, you can go. You got about 15 minutes. Okay. Thanks for asking. So there's our answer in joules. But we're not done yet. All we did was heat the water up. So you put a pot of water on the stove, Connor, you gotta heat the water first. It doesn't just start boiling. So you gotta raise it up to 100. Once it hits 100, then it starts to boil. You get that plateau, we're boiling. That's section 2. Now you use a different equation. Q is equal to mass times the delta H of vaporization. Our mass is 10 grams. Delta H of vaporization is 2,260 joules per gram. That's the amount of energy it takes to boil. But we're not done yet, Igor. Because they want to take that boiled water and they want to raise the heat of it to 175.